Hi folks, welcome to part 2 of the Unit 7 Lesson 4 videos. So let's take a look at number 3 here. So here it says determine the nature of the intersections of the three planes given. So notice here I'm not asking for the actual intersections, I just want to know what's going on in terms of these three planes. And of course when I say the nature of the intersection, one possibility is that there's no intersection. Alright, so what we saw in the previous videos, we can do everything using the normal vector. So the first thing I'm going to do is I'm going to specify my normal vectors. So here I've got n1 is 1, 1, negative 2, and 2 is 1, 1, negative 1. So again, I'm just looking at the coefficients of x, y, and z, and then n3 is equal to 2, 2, negative 4. And the first thing I want to look at is to see if there's any parallel vectors. All right, so clearly these two vectors are not parallel because the x and y components are the same, but the z components are different. But I notice here that the first and the third, I see that n3 is equal to 2 times n1. Excuse me. So these two are parallel, but the third one is not. Okay, third is not. Okay, so what does that tell us that we have is we've got two parallel vectors and one that's not. But there's two scenarios, okay, because we can have these two here that are coincident, or they could be parallel and distinct. So let's look at 1 and 3. And here I see that the factor that joins the two normal vectors is 2. And if I look at D2, I see that I guess this would be D3. So the D value for 3 is equal to 2 times the D value in 1. So that means that they're coincident. Okay, so here we have two coincident planes and one non-parallel. Okay, so let's remember what that looks like. If I have two coincident planes and one that's not parallel, I actually have an intersection in a line. Okay, because remember, this is just a cross section. This you have to think of coming out of the paper. So here, infinitely many solutions. All right, so let's take a look at B here. So let's write out our normal vectors. So n1 is equal to 1, 2, 1, and 2 is 2, negative 1, 1. And then n3 is 3, 1, negative 2. All right, so let's take a quick look. These two are clearly not parallel because 1 times 2 is 2, but doesn't work for the others. 1 times 3 is 3, doesn't work for the others. These two, again, not parallel. Okay, so that means it's one of the three scenarios where we have non-parallel vectors. So the question is are these normal vectors coplanar or not? So that's what I'm going to test here. All right, so I'm going to take the cross product of, say, the first two. This will work for any combination. So let's take the cross product of the first two. So 1, 2, 1. And here we have 2, negative 1, 1. Bring over the 1 and 2. So the cross product is going to be 2 plus 1 is 3. All right. Here we've got 2 minus 1 is 1. And here we have negative 1 minus 4 is negative 5. And now I'm going to dot that with the third vector. So here 3, 1, negative 2. And what do we get? We get, well, 9 plus 1 plus 10 is not equal to 0. Okay, so since there's no parallel planes, and I've got the scalar triple product not equal to 0, therefore intersect in one point. Okay. All right, let's move on to the next one here. So let's look at our normal vectors. So n1 is 1, 1, 2. Okay, and here we've got n2 is 1, negative 1, negative 4. So here I see right away that these are not parallel vectors. All right, and then here n3 is equal to 3, 5, 12. And again, this is not parallel to either of the other two. Okay, so if I multiply this by 3, say, well, it's not going to work for the other two components. All right, so let's go and find the scalar triple product. So Again, start for the first two, 1, 1, 2, and the other one is 1, -1, -4. All right, so here, bring over the 1, 1. So what do we have? We have -4 plus 2 is -2. 2 plus 4 is 6. And here we've got -1 minus 1 is -2. All right, so -2. And now I'm going to dot that with the third vector, which is 3, 5, 2. And let's see what we get. So we get -6, and that's going to be plus 30. Okay, and that's going to be, oh, sorry, I just realized this should be 12. I just noticed that there. I accidentally wrote 2. And so what do we have here now? Minus 24. So let's test. -6 plus 30 is 24. Minus 24 is 0. Okay, so what we know is that this is one of two scenarios. Okay, it's either the triangular prism scenario or it's the star or asterisk scenario. Okay, unfortunately, we can't tell easily which one of these two. We'd actually have to go and solve this system of equations to figure out whether I had infinitely many solutions if it intersects in a line, or no solution if it intersects in this triangular prism. Okay, but we know that it's not one of the first 5 that involve parallel planes, and we know, more importantly, that it's not a scenario that has a unique solution. Okay, so let's do this one last one. Okay, just to test it out. So here we've got first one is 1, -3, -2. Second one is 1, 11, 5. And here, and 3 is 2, 8, 3. Okay, so again, notice here we want to start getting really good at this cross product so that it can be done quickly. So 1, 11, 5. Bring over the 1, 1, and let's take the cross product. So here we have -15 plus 22. So that looks like it's going to be 7. So here we have -2 minus 5, -7. And then here we have 11 plus 3 is 14. Okay, and let's take the dot product with 2, 8, 3. All right, let's see what we get. So we get 7 times 2 is 14, minus 7 times 8, 56. All right, and then here plus 14 times 3, so 3 times 4 is 12. 30 plus 12 is 42. And I believe that's going to give us 0. Yeah, because 14 minus 56 is -42, plus 42 is 0. So again, we have these two possible scenarios, okay? But without doing any further investigation, I can't be sure which one of the two it is. So out of the 4, there's only one that has a unique solution. And you notice here that that's the one that I'm going to ask you to solve, okay? We're going to work on all of these types and see where the algebra takes us, all right? But what I want you to try, and again, use what we did for intersections of two planes as inspiration for how to start and see how far you can go. Okay, we'll take this up a little bit in the last part. Okay, that's it for this one.